Hello friends, welcome back to my channel. In this tutorial, I will show you how you can create this kind of cool water splash effect in Houdini. In this first part, I will show you flip fluid simulation, and in the second part, we will cover rendering in Solaris with Karma XPU. Without getting late, let's dive inside Houdini. If you are new to my channel, make sure to subscribe. I will create more effects and Houdini tutorial videos so you can watch and learn new tips and tricks easily. So here we are in Houdini and this is our Pepsi can 3D model ready. And now I will start with create emitter, make a geo folder, rename it to emitter. This will be our source for the particles. Create a sphere for the source, make it to polygon, frequency to 15 and resize it to 0.3. Now move its position. This is better. Now add a mountain node for the particles variance. Change the amplitude to 0.2 and change the element to 0.5. Now you can see it has been distorted. Now I will check the animation so you can see it is animating per frame. Now I will add point velocity for the direction of source particles. Add velocity. You can see it will go to the z direction. Make it to 5 or you can change as you want. We can change it later if it is not best for us. Now go to curl noise, add curl noise and then scale it to 0.3. Now you can check it is animating. Now add a ice offset. For the scattering of particles, change its uniform sampling divisions to 30 and then add a scatter node. Force total count to 10,000 and uncheck the relax iteration. Other things we will change later if we required. Now add a null and make this to emitter out. Now our emitter is ready. Go outside and make a new folder. Here our simulation will process. Make it to sim and add a dropnet. Rename it to flip splash. Go inside. Here only output node is available. Here we will add few nodes. First of all, I will add flip object. Second one is flip solver. And the third one is volume source. And the fourth one is gravity. Flip object to the first input and volume source to the sourcing or last input. Now add the flip solver to gravity and gravity to the output. Now you can see in the viewport, there are particles visible. Now we have to change few things here. First of all, we will cover flip object, make particle separation to 0.05. Now you can see particle count is increasing, but first of all we need to remove this subpath, make it blank, and in flip object we have to check this close boundaries so our particles will collide with this bounding box and don't go out of this bounding box, and change the jitter sheet to 1. And you can also change grid scale, don't go too high or too low. I will make it to 1.5. And in the creation there is nothing to change, and in the guides no change, and physical tab there is nothing to change, but I will use viscosity. Because of viscosity fluid will look more splashy. I will choose 0.2, and in the collision there is nothing to change. And the second one is volume source. Here I will add emitter. Go to emitter folder and choose our emitter out, and then in the initialize choose source flip. I will change the direction later, and in the particles remove this particle, and there is nothing to change. Now first of all I will resize this bounding box. Go to the volume motion tab and resize the box size. In the G direction I will make it to 15, and in the Y direction I will make it to 10, and in the X direction I will make it to 7. I will resize this because our source is here and particles will go to the Z direction, and you can see Y size is 10, so I will place it to on grid, so you can copy parameter and paste the box center to relative references, divide by 2, so always it will place on the grid. Now you can see this is very big, so I will resize again. Now this is looking better. Here is our source particles. We will check this. First of all I will go to substeps in the flip solver. Minimum substeps to 2 and maximum to also 2. You can go forever, but it will increase your simulation time. Now in the particle motion tab there is nothing to change, but most useful is receding particles. Make sure it is checked. Now in the volume motion there is nothing to change. I have already changed the bounding box or our box size, and I will stick with flip splashy because I need splashy liquid, and there is nothing to change. Now I will check what's happening. Our particles are falling down because of There is no velocity. I think we have to change our point velocity from here to here. Now this is better. Make sure to add point velocity after the scattering points. Now go to sim folder and in the flip solver you can see it is continuously emitting particles, but we don't need continuous emission. So go to volume source and in the advection here we will add an expression dollar $ff smaller than 20 because we want to emit particles only for 20 frames. Now you can see after 20 frames it is stopping to emit particles. Now this is much better. Now for the collision of the our particles to our can, I will add a static object. Add a merge node and connect it with merge. Now you can see it is going to the right direction, but you have to change it from here. First static object, then our string. Now in the static object choose the subpath. In the subpath I will choose from our can model collision out. This is VDB. You can see here again in the can model. This is our polycan model, but I have taken it from here polycan from the object merge and then added VDB from polygons to make it VDB for the collision and change the voxel size to 0.006 and then collision out. Now you can see this is our collision object. Now particles will collide with it. Now go back to the sim and change and check it again. You can see our particles are colliding and is separating, but our particles are very few, so they are barely visible. So I will change the particle separation to the 0.03. Now it is looking much better. For the tutorial purpose I am not going below because if your PC is not high end it may crash. So this is nice. There is nothing to do. Our particles are ready, but you can see it is easily simulating. So you can go below 0.015. The more the particles and the more the quality you will get, but it will slow the simulation and increase the simulation time. Now I will add doc.io. Here two nodes given, dop import field and file cache. File cache is for the particles to catch on our disk. First of all In the dop import field, I will select flip splash dop network and add to dop import fields dop network. Then in the dop import field, choose flip fluid, and then for the file cache, rename it to particle cache, and I will change it to node name, and then I will right click on 240 and select delete channel because of I only want to simulate it for the 150 frame. So I will add 150 sub steps to only one, but uncheck this version. Now this is okay, and now you can save it to disk, and you can also change the base folder name geo particle cache. Now save it to disk. You can see our particles are saving to my disk. I will back after catching completed. So now our particle catching is done. Now you can check load from disk is checked, and we can simulate it live. Now add particle fluid surface, and you can see particles are gone, but there is mess, but it is very scattered. So reduce the particle separation 0.05. Now you can see it is looking much better, but we have to reduce more 0.01. Now you can see it is ready and looking much better. I will not change anything here. You can change the influence scale to 4. So you can see there is tendrils like geometry formations, and in the output I will not choose surface VDB here. I will stick with surface polygon soup. First of all, I will catch this. I catch the disk because it will not simulate in the real time. For the rendering purpose, it is necessary to catch the particles and particle fluid surface both. Now this is surface catch. Like before, I will uncheck this version, select it to node name and geo surface. I will rename it to geo surface. It will go to the another folder. This is our folder name, and this is where our project is placed. Now you can see it is in my F drive in the tutorial folder. This is our project file which is hip, and there you can see this is hip, then geosurface. It is our geosurface folder. Like before, I will delete channel and make it to 150, and then catch it to the disk again. Now you can see our surface catching is started. After completion of this catch, I will back again. Now our surface catching is done. You can see this is scattering more. There is lot particles which are spreading. You can change your particle counts here in the particle separation. You can reduce it, or you can change also grid scale to 1, but I will stick with 1.5 for the tutorial purpose. It is much better. So I will show you. You can see this is looking much better. Now if your surface is looking scattered or rough, you can add BDB from polygons. I have to change its resolution or voxel size to 0.01. Now it is looking much better. Now I add a VDB smooth. Now it is looking more smooth, but I don't need this. So I will remove. It is looking much better. You can also change 0.00, 0.008. Now again you have to convert it to polygons to render it. So I will add convert VDB, convert to polygons. Now you can see our fluid is back and it is looking much better. So I will take pen plane for the rendering purpose. So here you can see how you can make this water splash. I will render it in the Solaris in the next part. Add a null. It is our splash. As you. In the next part, I will render it in the Solaris with Karma XPU. Make sure to watch. If you have any question, please comment below. Thank you for watching this tutorial. I will see you in the next tutorial.